Okay, here we go. 6i, summing of an arithmetic series. This is also called partial sums of APs. The reason why we call them partial sums is because we might be adding up, say, the first 5 terms of an arithmetic series. We never add up the whole of the arithmetic series, we just add up a set amount of terms. So we might add up the first 5 terms, we might add up the first 10 terms, we might add up the first 100 terms, something like that. Okay, so that's why we call them partial sums. Now there's 2 formulas that we use to do this, and I'll just go through these now. Okay, the first one we use is Sn equals n over 2 a plus l. Okay, so Sn stands for the sum to n terms, or the sum of n terms. Okay, n is the number of terms. A is the first term, and L is the last term. That's the first formula. Okay, the thing to remember with this is we only use this equation when we have the first and the last term. Okay, that's the only time we use this. Okay, only use this when we have the first and the last term. Okay. Okay, let's do one. This is obviously the sequence of even numbers. So if we were going to sum, say, the first 25 even numbers, we'd write it like this. So we've got 2 plus 4 plus 6 plus 8 plus ... plus 50. Okay. So the first, if we were summing all the even numbers up to 50, or the first 25 even numbers, okay, we know a few things about this AP. Okay, we know the first term A is 2. We know the last term L is 50. So because we have the first and the last term, we can simply use Sn equals n over 2 A plus L. Okay, so what we're saying is that S25 equals 25 over 2. The first term is 2, the last term is 50. Okay, so we've got S25, or the sum of the first 25 terms, equals 25 over 2 times 52. Okay, so this becomes 650. Okay, now let's see what happens if we don't have the first. Okay, if we don't have the first and the last term, but we know the common difference, we use this equation. Sn equals n over 2, in brackets, 2a plus n minus 1d. Now, if you want the proofs, or you want to know how these equations have been derived, you can just look in Cambridge to see those. Okay, I'm not going to do those here now. Okay, so same thing again. Sn is the sum of n terms. Okay, n is the number of terms. A is the first term, and D is the common difference. Okay. So the thing to note about this one is we only use this. We must know A, the first term, and the common difference. Okay, if we know the first term and the common difference, we can use this equation to find the sum of however many terms. Okay. Alright, so let's do a question. Okay, here we go. Let's do the same one as before. You'll find this will work as well. So here we go. Let's say we're doing this. 2 plus 4 plus 6 plus 8. Right? Okay, and let's say we were asked to find the sum of the first 25. Okay, alright. Well, we know here in this case that the first term is 2. We know the common difference is 2. Okay, so we should be able to use the equation. We're finding the sum of the first 25 terms, so n equals 25. So let's see how we go now. Okay, so using the equation, we know that Sn equals n over 2 in brackets 2a plus n minus 1 d. Now you have to know these equations off by heart. Okay, so S25 equals, now the number of terms is 25 over 2 outside of, now 2a, 2 times 2 plus, this is 25 minus 1, and d is 2. Okay, let's have a look now. So we get S25 equals, run it through the calculator, okay, and you find we get the same answer again. Okay, so either method does the same thing, but just remember, if you've got the first term and the common difference, use this equation. Okay, first term and common difference, use this equation. First term and common difference, use this equation. Okay, if you know the first term and the last term, okay, then use this equation. Okay, I always do that with my brackets, get the second one the wrong way. I'll be expecting Pierre Curie to write a comment soon about the way I do my brackets, but anyway, I'll just leave that for him to do soon. Okay, alright, let's do something a little bit tougher now. Okay, so what I'm going to do now is, out of 6i, I'm going to do question 3a, okay, because this is how we normally get these questions, okay. Normally you're not told what formulas to use, but this is a good example. So normally you can be asked to do something like this. Find the following partial sum, okay. So find the following partial sum, and it'll be something like this: 50 plus 51 plus 52 plus ... plus 150. Okay. Now, when we look at this partial sum, you'll notice that you're not told how many terms are actually in the sequence. Okay. So the first thing we have to do is we have to find out how many terms are in the sequence. So we have to use the Tn formula. Okay. So we know that Tn equals a plus n minus 1d. Okay, so we know the first term is 50 and the common difference is 1, so we can find out what term 150 is. Okay, so I'll just say that again. We know the first term is 50. Okay, first term is 50, a is 50. We know the common difference is 1 because we're adding 1 each time. Okay, so we need to find out how many terms are in this series. So to find out how many terms are in this series, we know that the nth term is 150. Okay, so here we go. So we know that 150 equals 50 plus n minus 1, and the common difference is 1. Okay, so 150 equals 50 plus n minus 1. So 150 equals 49 plus n. So n equals 101. Okay, so what that means is, in this arithmetic series, okay, there is 101 terms. Okay, now that we know there's 101 terms, we know the number of terms, we can actually find out the sum of these 101 terms. Now, the thing is, in 2-unit mathematics, we have to decide which of the two equations, that is the Sn equals n on 2 outside of a plus l, or Sn equals n on 2 outside of 2a plus n minus 1d, is the best one to use. Now, if you notice here, we've got the first term and we've got the last term. Okay, so because we've got the first and the last term, I think the best thing to do is to use the equation for having the first and last term. Okay, so this quickly becomes S101 equals 101 on 2 outside of A, the first term is 50, okay, plus the last term is 150, okay, so we get the sum of the first 101 terms is 101 on 2 times 200, okay, so the sum of 101 equals 101 times 100, which equals 10,100. Okay, so sometimes the questions are a little bit tougher and we have to find out how many terms are in the series before we can actually calculate the sum of it. Okay, alright, so three things. Firstly, make sure you know your equations off by heart. Second thing is selecting the best equation for the question you have. And the last thing is sometimes you have to actually apply the nth term equation to actually determine how many terms are in the sequence before you can actually calculate. These are the questions. So, out of 6i, can you please do the following? Okay, can you please do question 2, 3, 4, 5, 8, and 11? Hamish, stop watching the patterns and get on with the work.